Unit 4, linear and absolute value functions, question number 6. So question number 6 wants us to solve real-world problems, linear functions, and interpret key features and determine the constraints in terms of the context. So the question says, Lila has a punch card for a local coffee shop. The function this represents the remaining value in dollars on the card after buying P cups of coffee. Okay. Each coffee costs $2. So each coffee costs $2. Okay. So let's try to identify something. So first things first, this equation looks like a general form: y equal mx plus b. Okay, where m is the slope and b is your y-intercept. Okay. Well, the slope is what's changing and the y-intercept is what you start with. So in this case, the punch card had $12 on it, and then every single time they were spending $2. Okay, because again, every time you buy a cup of coffee, it's $2. So again, this will be your slope. Okay, and this is your y-intercept. Alright, so what we're going to do, guys, is that we're going to use this equation to answer the first part of the question. So it says, how many cups of coffee can Lila buy with her punch card? Well, we have this equation where it says 12 minus 2p. Okay, we know that p, as it says, represents the cups of coffee, and it wants us to find out how many cups of coffee. Alright, so what I'm going to do is that I'm going to replace this function right here with 0, and I'm going to go ahead and solve for p. Okay, so what I'm going to do first is that I'm going to move the constant to the left side by subtracting 12, so that I have negative 2p is equal to negative 12. Then I get rid of the coefficient by dividing by negative 2, dividing by negative 2. So p is equal to negative 12 divided by negative 2 is positive 6. So this 6 is the number of cups of coffee they would need to be able to buy to use up the entire punch card. Okay, so 6 cups of coffee. Okay, so now we're going to go ahead and answer the next part of the question. Okay, so it says select the choice that best represents the appropriate domain for the situation. Alright, well, what we need to do is that we need to remember, what does domain mean? Well, domain represents my x values. Okay, so that's what domain is. Domain are my x values. Alright, so in this case we don't have x values, okay, because again the x value is what you're inputting. So in our equation we don't have x values, we actually have p values. Okay, so in this case we're not looking at x values technically, we're looking at actually p values. Okay, and then p represents the cups of coffee. Alright, so in this case, if I want to look at the restraints, I need to figure out what can I not have, because a restraint, okay, or rather, yeah, what represents the appropriate domain, we need to essentially figure out what is going to be outside a restraint. So what can I not have? Well, I can't have negative cups of coffee. Okay, I have to have positive cups of coffee. So in the first thing I need to know is that p needs to be positive. Alright, so p needs to be positive. Okay, so p needs to be positive. Alright, so that's the first thing. Okay, what else? Well, you can have half a cup of coffee. Okay, so that's a something, so it can be a decimal. Alright, so it can be a decimal. Okay, so it can be a decimal. Alright, so this decimal. Alright, so that's something that I know, it can be a decimal. It needs to be positive. What else? Well, that's about it. Okay, so for the most part I can have 6 cups of coffee. It needs to be positive and it can be a decimal. So here it says that p is greater than 0 and p is a whole number. Well, could I have half a cup of coffee? Yes, I could have half a cup of coffee. So in this case it doesn't meet my 2 criteria. Alright, so this is wrong. Okay, so what about this one? It says all real numbers. Well, a real number is a number from negative infinity to positive infinity that includes decimals. Alright, but can p be negative? No. Alright, because a real number is anything that's not imaginary. Alright, so in this case it can be negative and it can be a decimal, so that's wrong. So here it's saying that from 0 less than or equal to c of P less than or equal to 12. Well, this is not talking about the P, it's actually talking about the function. Alright, so in this case it's not talking about the same thing that we're focusing on. So this one's wrong. Okay, so here it says that P is greater than 0. Alright, so in this case P would have to be all numbers greater than 0 are positive numbers. Alright, and in this case we're not doing any restrictions saying that we can't have decimals. So this would be the result. Okay, so again guys, just like that. Alright, so let's try the next one right below. Let's try the next one. Okay, so in this case the question says Alex receives a $100 gift card for a local movie theater. The function is given as this, and it represents the remaining balance in dollars after purchasing T movie tickets. How many cups of coffee can so this is talking about coffee, so this was said the wrong way. Right, so how many movie tickets can Alex buy with their gift card? Okay, so in this case, all right, we know that T is the amount of movie tickets. Okay, this is our equation. So 100 minus 12.50T. Okay, we know that this 100 is what we're starting with. Okay, because that's the initial value, and this negative 12.5 is how much we're paying for every single movie they go to, because T represents the movies. Okay, so again the 100 is like the y-intercept, and the negative 12.5 is your slope. That's how it's changing. Okay, so to find out how many movies I can attend, alright, I'll replace this function with 0, and I would solve for T. So I'll move the constant to the other side by subtracting 100. So 0 minus 100 is negative 100, is equal to negative 12.50T. So then I would get the T by itself by dividing by negative 12.5, divided by negative 12.5. Okay, 100 divided by negative 12.5, or negative 100 divided by negative 12.5, and negative divided by negative is a positive. Alright, and then 100 divided by 12.5 is 8. Okay, so T, or the amount of movie tickets we'll buy, would be 8. Okay, so we're gonna buy 8 movie tickets. So that's the total amount of tickets I can buy with $100. Okay, so now we're going to answer the next one. So this next one says select the choice that best represents the appropriate domain. Your domain are your x values. So again, your domain are your x values. Okay, in this case we don't have x. What do we have? We have, for the input, t. T is the input. Okay, so we actually have t values. Okay, so in this case guys, I need to look for any restrictions. Well, movie tickets can be what? It can be negative. Alright, and can you have half a movie ticket? No, you can't have half a movie ticket. Okay, so the first one, it says T is greater than 0, so that means that again we know we need to have that T needs to be positive. Okay, so it needs to be positive. Okay, and then in this case it cannot, so it cannot be decimal. Alright, because you can't have half a movie ticket. Alright, so in this case this is saying that T is greater than 0. What are some numbers greater than 0? 1, 2, 3, but also decimal numbers. 1.5 is bigger than 0. 1.8 is bigger than 0. 5.5 is bigger than 0. So again, this includes decimals. But can we have decimals? No, because you can't have half a movie ticket. So this one's wrong. So this one says all real numbers. All real numbers also includes negative numbers. So this will be also wrong. Okay. This says from 0 less than or equal to m of t less than or equal to 100. What is this talking about? This isn't talking about T, this is talking about the entire gift card. Alright, so this isn't even talking about the right thing. Okay, this one says T is greater than or equal to 0. Okay, because can we have 0 movie tickets? Yes, we can. Alright, and then T has to be a whole number, so it cannot be a decimal. This is the one that would be the result. Okay, so again guys, just like that. Alright, so let's try the next two guys. Let's try the next two real quickly. In 3, 2, 1. So the next two, all right, the question says Marcus has a prepaid parking card with $50 on it. Each hour of parking costs $5. The function is given as this. It represents the remaining balance in dollars on the card after parking 8 hours. Okay, so 8 is the amount of hours. Okay, and then it says each hour they're paying a $5 cost. So if I'm paying, I'm losing 5. Okay, so it says how many hours of parking can Marcus use with the card. So again, this is my function, and I'm trying to find how many hours. I'm trying to find h, and I'm trying to find h when the resultant is 0. So again, I would subtract 50, so I have negative 5h is equal to negative 50, divide by negative 5, divide by negative 5. So h is equal to negative 50 divided by negative 5, negative divided by negative is a positive, 50 divided by 5 is 10. Okay. Also, I want to add that the reason why we represent this as 0, because we're trying to say that if we were essentially supposed to make or if we're essentially supposed to have a total of 0, right, or the result of 0, what's the maximum amount of hours I would have, right? So it's similar to trying to find a y-intercept. Okay, so it's similar to finding a y-intercept. Okay, what would I need to be at to have a certain amount of hours? Okay, so 10 would be 10 hours of parking. 10 hours of parking. Okay. Alright, so I need to now look for my restrictions. Okay, so again, domain represents your x values. Okay, in this case, we don't have x values, we have h values, because h is the input. Alright, so h values is actually what we're looking at. Okay, so what's the criteria for my h values? So, well, h has to be positive, because again, we can't have negative hours, so h has to be positive, so needs to be positive. Okay, what else? Can we have half an hour? Yes, we can have a decimal. Alright, so we can have decimal. Alright, decimal. So we can have a decimal. So those are the main criteria. Okay, so in this case here it says it's greater than or equal to 0, because we can have 0 hours. Okay, that works. But here it says that t has to be a whole number, but t doesn't have to be a whole number, because hours can essentially be a decimal. So this one's wrong. Okay, this one says all real numbers. That one would not be accurate, because all real numbers includes negatives. Okay, this is talking about the wrong function. It's talking about the y, or the output. Okay, because it's talking about the entire function. And then here it says h is greater than 0, so this is the best one that fits it. Okay, because again, this would include decimals, and it includes the positive numbers. All right, even though it doesn't include 0, it's the best one that works. Okay, it's the best one that works, because you can technically have 0 hours. All right, but in this case, it's the one that includes all the different parameters. All right. So then let's do the last one, guys. So it says a cafe selling a prepaid, or rather, a cafe sells a prepaid juice card with $30 on it. Each juice pack costs $4. Okay, so that's important for us to know. This is the function which represents the remaining value in dollars on the card after P juice packs. Okay, how many juice packs can the customer buy with the card? Well, we're gonna say that 0 is equal to 30 minus 4P. Then we're gonna subtract 30. So we have negative 30 is equal to negative 4P. Or divide by negative 4. Divide by negative 4. So P is equal to negative divided by negative is a positive. 30 divided by 4 is 7.5. Alright, so we would have 7.5 packs of juice, or we're going to be buying 7.5 juice packs. Okay, so 7.5 juice packs. Alright, so 7.5 juice packs. Okay. So then now we're going to identify the domain. So again, most of you guys should probably can realize what the domain is. Okay, so domain are your x values, and again, you need to be writing out every single thing that I write, because I don't write it for me, I write it for you. This is for your learning, for you to learn. Okay, oh, not p, not t, but p values instead. So what are the restrictions for P? Well, P has to be positive because you can't have negative juice packed, so it has to be positive, so it needs to be positive. Okay. And then what else? Well, it can be a decimal because we literally got a decimal, so it can be decimal. Alright. And I think that's about it. Okay. So this is saying that P is greater than or equal to 0. Alright. This does include decimals, includes 0. Alright. This one says P is less than or equal to this and less than 7.5. These ones are pretty close. The only one that's not close is this one, alright, because this is talking about the y value. So but a lot of these are pretty close. So P can be less than or equal to 0, but this is the largest it can be. This is actually the more appropriate domain. Okay, the reason why it's the most appropriate domain is because at 7.5, if I plugged in 7.5 in the equation, 4 times, or negative 4 times 7.5 would be negative 30. 30 minus 30 is 0. Alright, so this would be the most I can evaluate it for. Alright, so this is actually be the more accurate version of the question. Alright, because we can have decimals, because this includes decimals, and this will be the lowest we can have, and then this will be the highest we can have. This is actually the best selection. These are also close, but this is better. Alright, so again, if this wasn't here, then I would choose in between one of these other ones. Okay, I would probably choose this one because we could have 0 packs of juices. Alright, so again guys, just like that.